problem 2850, minimum of moves to spread stews over grid. So for this problem, we are giving a fixed grid, so it's going to be 3 times 3. So it's going to be represent the number of stews in its cell. So the grid contains exactly 9 stews, and there can be multiple stews in a single cell. Yeah, so let's just use the first example to explain it. So in one move, we can move a single stew from its current cell to any other cell if the two cells share a side. So we're going to return the minimum number of moves required to place one stew in each cell. Yeah, I think we should understand the description of the problem, because the description is not so long and it's not so difficult to understand. Yeah, so for the first example, normally for each of the cells, we're going to give a stew, and in this cell we have one stew, it is okay. And this is one, okay. Yeah, so for all the ones, it is already okay. But for this one, it is a 2. So this means we need to give one stew from this cell to another cell, which is a 0. So how many steps? So because if it is a neighbor with each other, we can move to, we can go to here. This is 1 step, 2 step, and 3 steps. So the minimum steps going to be on 3. This is why we're going to return a 3. So after that, this cell going to become 1. Yeah. And let's just check another example. Maybe the second example is more representative. So in the second example, we have 1, definitely it is okay, but this is a 3. So this means I would to give a neighbor to this one, and I would to give a neighbor to this one, and for this 3, I would to give a neighbor to the top one, and I would like to give a neighbor to the left side. So in total, it's going to be 4 steps, and this is going to be the minimum number of steps. But how can we solve such kind of problem easily? I mean, we are giving a 3 times 3 grid. Basically, this is a fixed grid, and it is not so big. This means maybe we can solve this problem by using the brute force. So the brute force idea is that basically we want to prepare 2 arrays. So the first array gonna be the move array. So this means everything inside of the move array, I want to move from this position to another position. I'm gonna call it receive. So this is gonna be a receive array. Yeah. So we're gonna basically prepare 2 arrays. So one is move, another is receive. So for example, this number is 1, it is okay, but what about the next number? It is a 3. Yeah, so basically if it is a 3, it means we're gonna keep 1 here. What about other 2? So we will keep 1 here, but there are gonna be other 2, so we're gonna record the places. So the places according to the row and column, it's gonna be 0, 1. So we have a tuple of 0, 1 here, and we're gonna prepare another tuple of 0, 1 here. We just put it inside the move array. And what about others? And this is a 0. Definitely we want to put it inside the receive array. So if it is a 0, it means we're going to put a tuple of 0 and 2 inside the receive array. And let's just continue. And we're going to put 1, 1 because this is a 0. So we're going to put 1, 1 inside the receive array. So inside the tuple, it's going to be 1 and 1. What about next? It's going to be 1 and 2. So we're going to put 1 and 2 inside another receive array. And let's just continue. And this is going to be 2 and 1. So we're going to put 2 and 1 in another receive array. So this is going to be the receive array. And this one going to be 3. So we're going to put 2 and 2. How many 2 and 2? So 3 minus 1, it's going to have 2. It's going to be 2. So we're going to have 2 and 2 in the move array. 2 and 2. Another one going to be 2 and 2. Yeah. So as we can see from the move and the receive, so the length of the move is going to be equal to the length of the receive. Both of them are going to be equal to 4. Yeah. So this means by making the permutation of this move, definitely we're going to have a 1-to-1 position. Yeah. So what is the permutations of this move? So it's going to be 4 factorial of 4. Yeah. So the factorial of 4 is going to be 16 different kind of combinations, and for each of the combination, we just need to check with this with the tuple inside the receive, and we can calculate the distance according to the description. And actually, it's going to be the Manhattan distance. So from here, we can calculate the Manhattan distance, and for the next permutation, we can continue to check the Manhattan distance, and finally, we just need to return the minimum of all the Manhattan distance. So this is just the idea. So the idea is not so difficult, definitely. And what is the maximum of this move? Because the maximum number can only be 9. Because after that, every cell gonna be 1. So the total sum of all the values is gonna be 9. So if the maximum number is 9, it means 9 minus 1 is gonna be 8. So it means inside this move or receive array, the maximum length is gonna be 8. So this means the time complexity gonna be 8 factorial. 8 times 8 factorial. So this is gonna be a small number. So that is why we can solve it by using the brute force. So currently it is 3 times 3, but what if it is 4 times 4? So it means it's going to be 15 times 15 factorial. Maybe it works. Yeah, because 15 factorial maybe it's not a big number. Yeah, but it's already big enough, I believe. Yeah, because 15 factorial definitely it's going to be, yeah, I think it's going to be really big. Definitely it should not work. Yeah, but what about, this is why they designed it 3 times 3, because only 3 times 3 works. If 4 times 4, so 15 times factorial of 15 is going to be a really big number. Let me just check that. So let's just print out 15 times factorial of 15. Let's just check this number. Yeah, so this is going to be a really big number. So if it is 4 times 4, as you can see, it's going to be a really big number. Definitely it should not work. That is why we are giving a 3 times 3 grid. So the time complexity is going to be 8 times the factorial of 8. And in this way, so this number is going to be a small number. Definitely it's going to be 3 times 10 to the power 5. This is why it works. Yeah. Now let's just use this idea to solve the problem. So I'm going to use the second example because this is more representative. So I'm going to prepare R and C as always for the grid. It's going to be length of the grid and length of the grid 0. And I'm going to prepare a move and receive array. It's going to be an empty array from the beginning, and I'm going to prepare a final result. It's going to be infinity. So finally, I'm going to return this final result. Now let me just loop through the array. Yeah, so we just need to loop through the array, row and column, and we need to check the values inside the grid. Yeah, so if the value is more than 1, definitely we're gonna put it inside the move array. So the move I'm gonna use extend because it can be several values. So inside an array, I'm gonna put a tuple with RC. So I need to times the value of the grid with RC and minus a 1. So if the grid RC can be 0, so if it is 0, definitely I want to put it inside the receive array. So the receive array gonna append a tuple with R and C. Yeah. So what happens for the move and receive? Let's just print it out to have a check. So basically, it is my explanation of the move and receive. For the first example, it's like 2, 1, go to 0, 2. And in the second example, those 4 tuples will go to another 4 tuples. So that is why we're going to use the permutation to solve the problem. Yeah. So next, we're going to use the permutation. So we're going to use for m in Python. We can directly use the permutations of this move array. And then we're going to check all the tuples. So for x1, y1, and another tuple going to be x2 and y2. So I'm going to zip it. So that is why I can use the tuples. Basically, it's in this one permutation of the move, and in another one, it's going to be the receive. Now, we want to get the total value. So I'm going to prepare answer going to be 0. So the answer going to plus equal to all the possible combinations. Yeah. So basically, it means this one go to this one, go to this one, and this one go to here and go to here. We just need to combine all the permutations. So as it will be the Manhattan distance, so it's going to be x1 minus x2 plus absolute of y1 minus y2. And finally, we're going to get the minimum result. So the result is going to be the minimum, actually. The minimum result with the answer. Yeah. Now let me just run it to check. As you can see, it works. Now let me just submit it to check if it can pass. Yeah, so according to our calculation of the time complexity, it is 8 times factorial of 8. Basically, it's going to be a small number. It is 10 to the power 5. That is why we can pass. As you can see, I think it is pretty fast, and this is okay to solve such kind of problem. Yeah, because definitely if you use another way, maybe network flow, it's going to be much more difficult than this. I think the brute force is enough to solve it. To solve such kind of problem, because we are giving 3 times 3. It is not 4 times 4, so I think it is okay. So thank you for watching. See you next time.